Welcome to the Bentley Systems training course to learn how to model gravity loads in the RAM structural system RAM Modeler. Over the next series of videos, you will learn how to model some gravity loads, which will include defining the member load in the self-weight criteria, modeling superimposed gravity surface loads, modeling gravity line and point loads, and also how to model snow loads in the RAM Modeler. In this video, you will learn how to model superimposed gravity loads in the RAM Modeler. All gravity loads imposed on a structure, with the exception of the self-weight, must be applied to the model as a surface loading, line loading, or a point loading. Before loads can be assigned to the model, they must first be defined in the property table for each load type. When the loads are laid out, they will be distributed to the supporting framing based on the tributary area and deck orientation of the slab or deck assigned to that level. Each of the superimposed loads that we will apply to the model consists of several gravity load types. The first load type we will define is our dead load, which will include any superimposed dead load on the structure, since we've already told the program to automatically calculate the self-weight. We can also enter the construction dead load, which will be used for pre-composite checks of steel member, and the value of this field must be less than or equal to the dead load you enter. You can also enter your live load, and here you should use your code suggested live loads based on the occupancy of your structure. You can also enter partition loads, and here you should also use your code suggested partition loads if applicable. The partition loads will be applied to the model as live load, but they will not be considered in the live load reduction calculations. You can also enter construction live loads, which will be used for pre-composite checks of steel members, and also this value must be less than or equal to the live load you enter. Finally, you'll also define your mass dead load, and this will be used to calculate your seismic loads in RAM frame. Typically, this would be the dead load of the structure, superimposed dead load, plus a percentage of the live load if required by your local building code. All of our superimposed loads on our model will be created in the RAM Modeler. So from the RAM Manager screen, I will go ahead and select the model icon, which is the first icon in the design toolbar. Now my first step to defining my surface loads on my model is to define them in my surface load property table first. To access my property table, I will go up to my layout toolbar, select my layout loads icon, and you can see these first four icons. These are to access each of my property tables, and I'll select my first one to access my surface load property table. Here I can enter all of the surface load types that will be important for my model. And as a reminder, RAM Structural System has indicated what I have already selected as my self-weight criteria from the RAM Manager. I'm first going to enter my first surface load property, and I'm going to enter what I'm going to consider my typical surface load. For a superimposed dead load, which would typically consist of any ceiling materials or floor surface materials, I'm going to enter 20 PSF. For construction dead load, I'm going to enter 5 PSF. For my live load, I'm going to enter 50 PSF and say it is reducible with a partition load of 15 PSF. I can also enter a construction live load of 20 PSF and a mass dead load of 20. Once I've entered all the appropriate information for my first surface load property, I can go ahead and click the Add button, and now you can see that this load is ready to be assigned to the model. Now I can complete as many surface load properties as are going to be necessary for my particular model. And for this one, I'm going to enter a few additional ones. I'm going to enter a separate surface load for my exit area, so that will allow me to enter a higher live load. So I'm going to call that exit. I'm going to keep all of the other loads the same except for my live load. I'm going to bump that up to 100 PSF. And I'm going to change the classification to unreducible. Now since my live load is 100 PSF, I'm going to remove my partition load, and then everything else would stay the same. Once I've entered all of my exit information, I'm going to go ahead and click on the Add button. Next, I'm going to enter some loads for my roof. I'm going to enter my typical roof area, and here I'm going to enter a typical 5 PSF. Now, since my roof area consists of just roof deck, it is non-composite, I can change my construction dead load and my construction live load to 0. I'm also going to enter a roof live load of 0 and change it to the roof live load type. If you recall, when we were in the RAM Manager, we specified to consider snow load and ignore roof live load. So I'm not going to put any roof live load here, but later on I will be modeling some snow load. I'm also going to change the mass dead load to 5 PSF. And then I'm just going to go ahead and click Add. Lastly, I'm going to enter one more roof surface load, and this time I'm going to define a separate surface load for the areas that have my steel joists in them. I do have some steel joists on this job at the roof level, and since RAM Structural System does not automatically calculate the self-weight of steel joists or any of the bridging that might be required for those areas, I should add some additional loading to account for that self-weight. So what I'm going to do is I'm going to enter a separate surface load property, and I'm going to bump up my dead load to 10 PSF and my mass dead load to 10 PSF as well. Then I'm going to go ahead and click the Add button, and now I've entered all of the surface loads that are going to be applicable to this particular project. Once I'm finished, I can go ahead and click OK, and now I'm ready to start modeling loads on this project. For this exercise, I will start modeling my surface loads on my structure, and I'm going to start at the first floor of my structure and work my way up. So my layout pull-down menu, I will now select the first floor layout, and I'm going to go ahead and start modeling just some typical surface loads here. Now you can see that since I've already entered some information in my surface load properties table, that now my layout surface load icon has become available to me. I'm going to go ahead and click on this icon, and here I can see all of the surface loads that I already created. I'm going to highlight the typical surface load, and then I'm going to go ahead and click on this whole floor button to apply this load to everywhere on this typical layout. And now I will repeat this process as I work my way up in the building. Next, I'm going to select my second floor layout. I'm going to right click to return back to the dialog I was previously in, and I'm also going to apply the typical surface load to this entire plan by clicking on the whole floor button. Next, I will work my way up to the third floor layout. I will right click to return to the surface load layout mode, and again I'm going to apply the typical surface load to the whole floor. Now for this particular layout, I would also like to model the exit surface load within this area here enclosed by grid lines D.5 and E. In order to do that, I can just right click to return to my surface load layout mode, and then this time I'm going to highlight this exit surface load and click the Add button. Now I will click on each corner that will define the polygon for this surface load. So I'll start by clicking on grid intersection D.5, 2, then I'll click on E2, E3, back to D.53, and then back to my starting location to define a new surface load. Now surface loads in RAM Structural System are not additive, so the load that is modeled on top will be considered. And on this plan I can see two distinct different types of hatching to help me identify where the extents of the different loads are. Now if I would like to change the order, I don't have to redraw my loads. I could just right click to return back to the surface load layout mode dialog, and I can change the priority if I want to. So if I want to remove this exit load, I can just use this up and down buttons to change the priority of it. But by default, the one that you modeled last will be considered in the analysis. I'm going to go ahead and click Cancel at this point because I like the way that these loads have appeared on my screen. Finally, I'm going to work my way up to my roof level, which is my last layout, and model my roof surface load. Again, I'm just going to right-click to return to my surface load layout mode, and I'm going to select my roof surface load and apply it to the entire floor. Then in this particular area enclosed by grid lines C and D.5, I can see that I do have some steel joists defined in this area. So I'd like to use my heavier surface load for my roofs to include some additional weight that those steel joists would be imposing on the structure. I will just right-click to return back to my previous dialog, select the Roof Joist option, and then I'll click Add, and then I'll create my surface load polygon. And again, we could see two separate hatch areas to define the different surface loads. All of the surface loads that have now been applied to the model will be translated to the supporting structure based on the orientation of the deck or slab that is assigned in that particular area.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.